Next, let's look at this problem over here. Here, we are given the force applied, the tangential force, okay, applied to the grindstone. We're given the radius of the grindstone. We're given the mass of the grindstone. We're told it's a solid disk. So let's start with the torque. So the situation here is we've got something like this, rotating about its middle, and this distance is 0.280 meters, and the force is applied tangentially 180 newtons. So the torque here, okay, is 180 newtons, the force, times the radius, 0.280 meters. That's 50.4 Newton meters. Now, we don't know if it's clockwise or anti-clockwise. So our direction might be wrong. But really, in this problem, all we care about is the magnitude. And this would not affect the results per se. Okay? Next, we need to find the angular acceleration. And the key to this is to realize that the torque is I alpha, where I is the moment of inertia. And we'll start by doing part I. If there is negligible opposing friction, then the net torque is going to be 50.4 Newton meters. Now, if I do that, then I'm going to have to find the moment of inertia. Moment of inertia for a solid cylinder. Now, we have to be thinking through this so that we can justify this. So really, it's a uniform disk. That's what we're assuming. And always what we see is, for a uniform cylinder, as long as I'm going through this axis, this disk is a very thin cylinder. So it doesn't actually make a difference. So we can use the formula for a solid cylinder. So the moment of inertia is half mr squared. So that's half times the mass, which up here we found was 75 kilograms. R is 0.280 squared. Number has to be in meters. So over here I have 2.94 kilogram meters squared. So if I have that, the net torque is I alpha. So 50.4 is 2.94 times the angular acceleration. So the angular acceleration is 50.4 divided by 2.94 is 17.1 radians per second squared. Now, what if there's an opposing force? Now, the frictional force exerts this torque. Now, over here, if you look at this, it tells us that the force is 20 and it's 0.015 meters away. So if I do that, I'm going to have to calculate. So this is the radius is 0.015 meters times the force of 20. Okay, and that would get me 0.30 Newton meters. Now this opposes the torque that is applied by the driving force. So the net torque is therefore 50.4 from before over here minus 0.30. So that's 50.1 Newton meters. If it's 50.1 Newton meters, then I can plug it straight back into this equation. So I alpha is 50.1. It's not going to make a huge difference. 2.94. Alpha is 50.1. So the angular acceleration here is 17.0 radians per second squared.